everyone, welcome back to another video from the Winter Forest. Today let's continue our leetcode challenge. Today's leetcode question is called binary tree level order traversal second. Let's look up the question. So you will be given a binary tree and they expected output, it is return bottom up level order traverse. So in here, the root nodes in the last one, and the first layer in the last second one, 9, 20, and the bottom in the first one, 15, 7. For this leetcode question, in the early days, it normally just a simple knowledge, understand the data structure. In here, actually, we're going to use a queue. And you could go Google and DQ Java, then you could search, find this knowledge if you have no idea what is DQ doing. And here also I found one, this quite a good one. They have a video topic and explain all of the queue related method. And how we use this technology and the DQ data structure to solve this one. We're going to draw a diagram. We're going to use this example to draw how it works in the queue. So for example, we have received a tree like 3, 9, 20, 15, and 7. We're going to have a queue. This is called a DQ. And the second thing we have the array. And it actually is, we also need a queue. This is called a linked list. Linked list, it is a queue. Because every time we only can start with the root nodes. As such, the online somebody just reverse, but we don't need it. So the time complexity will be all so looping through all of the data. So the first one we're going to have the 3. So we're going to offer the 3 in here. Once we are in, we also immediately we pop this up. Immediately we just pop 3 up and we push it into array. Once this popped up, we're going to push this one, this root nodes left, if not empty, push the in. Then if it's right not empty, also push the in. This step haven't finished. Once finish push, you also put this one into your result. At the moment it's empty, so you just push the in. And then do second loop. Second loop we're going to DQ this. If this is not empty, this queue not empty, we can DQ it out. Once we DQ it out, so this one is empty. Every time we go into DQ something out, we check the left and the right is empty or not. We check these nodes left, right, empty. Yeah, we don't put it into queue. But the 20 is not empty. We push the left in first, then push the right in. Here once we popped up, this haven't finished yet. This we need to do extra step. So in this one, instead of push into, that is why I need a linked list. I will push into the first item, the linked list. So you have the order. So so now it change to 3 will be there, and the 0 position it change to 9 and 20. So instead of pushing in the back, put on the after 3. Instead, put in the 0 position in this result list. We call this RES. Now it change to like this. And now finish this one, 920 finish it. We're going to do, now this is finished, move to here. Now we're going to DQ this one. Once we DQ, check they have a child or not, left and right. They don't have. So this queue is empty. So this tree is looping finished, but here this step haven't finished. We need to do one step to do the result. This one always push into the head. So in the 0 position. Now you have the output is 15, 7, 9, 20, and 3. So this is going to solve the problem. And so they have two knowledge. One is called a linked list. Linked list, it is implemented the queue. Second thing, it is called DQ. So every time we start with the root loss, then we check this size. This size is 1. So once popped up, it already finished. Once this pop up, we push the chart. Check if it's null or not. If it's null, we won't push it in. If it's not null, we push left, then push the right. Now we could write our code. So what we need a list. The result is list, an integer. So this is the expect output. We just copy here. So this is the result. First, we check the edge condition. So if it is the root is empty, we don't need to do anything. So it's an empty result. Otherwise, we're going to start the loop. What I draw. So we have the data structure. We're going to use DQ. First, we push the root in. I'm easy typing English, no, so I just use less character. If this queue is not empty, we're going to loop it, push into our result. If it's not empty, then we check current v of the 1. So the size is 1. We know this size, then we're going to understand how many array, how many lists needed to, how many loop we need a loop for finish and this level. This is the shortcut. This will check size is greater than 0 or not. Finish one loop, it come into here, then minus 1. You have the 3 nodes. The current one. We pull out, then we add into this list. We haven't finished yet. We check left and right. If left not equal to null, we need to put the child. So the child binary tree only have either is left or right. If left has value not equal to null means has chart, then we give current dot left in, push the in. Afterwards, we also check current dot right. If also not equal to null, we also push into the queue. Once this while loop, this one layer loop finished, then we have this list we push into our result. We always add into the 0 position. So it will be so we are going to don't need in the end travel reverse it. Once this finished, the whole tree traverse finished, you just return your result. Let's test it, see if I have a syntax issue. It looks fine. It is just the example and passed. So we just submit and see if it pass other scenario. Yeah, it accepted. Thank you for watching. Bye.